I'm Bill Cox, Chief Technology Officer of the Energy Mashup Lab. This talk gives a technical overview of the lab's open source Transactive Energy Implementation, EML-CTS. We're using and applying a specification, the Common Transactive Services, to drive a simple, effective, extensible, and open implementation in order to accelerate use of transactive energy. The Common Transactive Services have been submitted to OASIS for standardization. See our website, theenergymashuplab.org, for the specification and links. All code is open source, Apache 2 licensed, and in public repositories on GitHub. The common transactive services were defined so that users or participants can have a consistent experience with transactive energy. They can be used to trade any product, energy, power, water, gas, regulation, and to trade on any market and with any market internals. The goal here, again, is to reduce barriers to transactive energy participation, enhance market and effectiveness and uptake, and enable simulation experiments and deployments. Why EML-CTS? What we've built is free and open software. It's under the Apache 2 license, so you can use it in any product, device, market, project, commercial, or research without royalties. It was implemented by the lab with NJIT student teams. We've integrated parity trading as a local market. Our matching engine, it's an efficient, scalable, open source market. More about that later. But most important, we've developed a clean, extensible architecture, easy to understand, easy to extend, easy to evolve. The goals for the EML-CTS implementation are, first, to have a clean, clear, simple actor implementation, straight through, scalable, robust, and deployable. Second, to be able to substitute markets. We provide an integration with parity trading, which is a reliable and robust open source market, but the delivered code shows you how you can integrate with any market. Finally, we have a structure that allows you to use other programming languages. Our development language is Java, but any language that can do RESTful web services with JSON serialization works. So the key here is we want to be able to substitute technologies, the users, the market, the database, and the messaging, and allow simple mix and match integration. The user view is straightforward. Participants, or technically the agents representing them, interact through a local market. A user will send tenders and offer to buy or sell and get back asynchronously transactions showing what was matched in the market, showing what was sold, how much, to whom, and what the price was. The user agent, in effect, is the integration point between the local market and the transactive energy sphere, and an energy manager, a device, an external microgrid, or, as we have done and we'll discuss in the next slide, thin glue code that brings an external market into the local marketplace. Now let's take a look at how EML-CTS is implemented to accomplish this view. Recall that each user, which could be an energy manager, a device, an external market, anything, connects through a transactive energy user agent, or TEUA. They all talk to the local market agent, which you can think of as a multiplexer consolidator of all of the local market tenders, which, remember, are offers to buy or sell. The LMA sends those tenders to the local market manager, which manages the interaction with the market and also converts from CTS messages or message payloads into whatever is appropriate for the matching engine. So this is the integration point for the market that's being used locally. The communication there then is to and from the matching engine. Our implementation, as I mentioned, is parity trading. So that adapter goes both ways, converts CTS tenders into matching engine syntax and takes matching engine matches and turns them into CTS transactions. Integration of the local or the external market or microgrid again uses exactly the same code, and the integration of any external market is quite straightforward following our code patterns. CTS is standards-based. The initial version was a subset of the Energy Interoperation tmix profile. We've now updated, simplified, and clarified it. And the spec contains payloads and expected interaction patterns and uses simplified WS calendar schedules and streams. We're consistent with the IEC Smart Grid user interface, and we're now implementing the fixed simple binary encoding. This is from the people who brought you sub-microsecond trades on the stock markets. The formal specification has been submitted for standardization. See the Energy Mashup Labs website news pages to get your own copy. EML-CTS is built in Java 8 using Spring Boot and MySQL Community Edition. We have integrated the parity trading system, which is the matching engine, and the client, which serves as our bridge to the parity market. The parity trading market is used unchanged. It's in fact generated from their source code directly. There are available stock tickers, tracing, market intelligence tools, as well as a simple way of shadowing markets for fast failover. In December 2020, we demonstrated Docker deployments of the matching engine and EML-CTS, as well as fix SBE for the link between the local market manager and the matching engine. Our work in progress as of February 2021 includes refining the actors for finer grained Docker deployment. Complete fix SBE is a pure to JSON serialization, and evolve our code base to Java 11. Some secondary tasks which may be accelerated with interest, funding, and contributions include complete the EI cancel tender, payload implementation, market contexts, multiple products, enhance support for market intelligence, and two internal things, limit database use to the LMA, and consider asynchronous messaging. In a distributed or Docker environment, this is less significant, as CTS is a payload spec, not a messaging spec. In conclusion, EML-CTS has met its goals: a clean, clear, simple actor architecture and implementation, evolving and expanding deployment options. You can substitute markets following our sample code, and a simple, stable API to support diverse participants in transactive energy. The source code is available now and as it evolves, and with your help, we'll build the future for EML-CTS. Please subscribe to our newsletter for evolution of the project and specifications. Thank you for listening.